Hello everyone, this is me Vignesh. Welcome back to my YouTube channel. Today we are going to tackle a challenging coding problem called edit distance on LeetCode. But don't worry, I will break it down step by step and explain each concept in a simple and easy to understand manner. So whether you are a beginner looking to improve your dynamic programming skills or an experienced coder looking for an fresh perspective on this problem, you are in the right place. Before we dive into the solution, make sure to hit that subscribe button and the notification bell so you don't miss any of my future coding tutorials. Now let's get started. Let's understand the edit distance problem. This is a classic dynamic programming problem that is used in various applications like spell checkers, DNA sequence alignment, and more. The task at hand is to find the minimum number of operations required to transform one string to another. These operations include inserting a character, deleting a character, and replacing the character. Each operation has a cost associated with it. Our goal is to minimize the total cost of operations to make the string equal. For example, if we have two strings, rs and rows, the minimum edit distance to transform rs into rows is 3. Here, here is how we can do it. So first we will replace h with r and remove r, then we will remove e so that it will become equal. In this video, we will implement the solution step by step. By end of this tutorial, you will have a clear understanding of how to approach dynamic programming problems like edit distance. To solve this problem, we use a dynamic programming approach, and here is how it works. So first, we initialize two variables m and n, which represents the lengths of word1 and word2 respectively. We create 2D array dp of size m plus 1 and n plus 1 to store our intermediate results. dp of I and j will represent the minimum number of operations required to convert the first I characters of word1 into first j characters of word2. We set up our base cases. These are initialized like this because converting a non-empty word into an empty substring requires this number of deletions, and these are initialized like this because converting an empty substring into non-empty string requires this number of insertions. Next, we will iterate through this dp array using nested loops. So for this column, we have the h is not equal to r, so we have to consider these three previous states. We take minimum of these three operations and add 1 to it and assign to the result. So these three states represent the minimum operations of the previous substring without considering the current characters. For this replace operation, the empty substring is replaced with empty substring with zero cost. So for now, just we have to replace this h with r, so it will become equal. And for delete operation, there is a string r before h, so we just have to delete this h character so that it will become equal. So for insert operation, there is no string, so we just have to insert the r so that it will become equal. So the answer is we need to find the minimum of these three steps and add 1 to it. So we take this one and add 1 to it and it will become 1. So we just go to the next slide. So for this column h is not equal to o, so we need to consider the previous three states. So here in replace operation, there is a string r before h, so we need to replace the h with r, so it will become equal. In delete operation there is a string ro and the current character is h, so we need to delete the h so that it will become equal to ro. So in insert operation there is a string r and we need to insert the o so that it will become equal. So in these three steps we need to find the minimum of this and add 1 to it. So we can go to the next slide. So for this column h is not equal to s, so we need to consider these previous three states. So for replace operation there is a string ro, so we need to replace the h character with s so that it will become equal. In delete operation there is a string ros, so we need to delete the current character h so that it will become ros. And in insert operation there is a string ro, so we need to insert an s into it so that it will become equal, and we need to find the minimum of these three and add 1 to it. Next, here the r is equal to r, so we can just replace this green one. So there is because there is no step required to convert this r into r, so we can use this one. For this column r is not equal to o, so that we can analyze these three steps. So for replace operation there is a string r, so we need to replace this r with o so that it will become ro. And for this delete operation there is a string ro and we need to delete the current character here r. So for this we need to delete the current character r so that it will become ro. And in insert operation there is a string r and we just need to insert o into it so that it will become equal. So in this operation we need to find minimum of these three and add 1 to it. So for this column we just r is not equal to s, so we need to analyze these three steps. For replace operation there is a string ro and we just need to delete the we just need to replace the r with s so that it will become ros. And for delete operation the string is ros, so we just want to delete this r so that it will become ros. In insert operation there is a string ro and we just need to insert an s into it so that it will become equal. By following this process for all possible combinations of I and j, the DP array gradually builds up the solution by tracking the previous steps, this ultimately leading to the minimum distance. So the result is 3. So you can refer this code. Here we are initializing the array, and then in this for loops we are iterating over the DP array, and if the character equals we can do this, and if the character not equals we have to find the minimum of these three steps. So thank you all.